Here we are going to discuss number 11. It says owners of a car rental company have determined that if they charge customers P dollars per day to rent a car, where P is greater than or equal to 60 less than or equal to 300, the number of cars N they rent per day can be modeled by the linear function N of P, where N is the number of cars and P is the price per car, is equal to 1050 minus 7 times P. Okay, so price is a variable and the function is the number of cars. So you can calculate the number of cars based on the price. So that is the number of cars function. Okay, 1050 minus 7P. Okay, now if they charge $60 per day or less, they will rent all their cars. If they charge $300 per day or more, they will not rent any cars. So they have to try to rent between $60 and $300. Now, assuming the owners plan to charge customers between 60 per day and 300 per day to rent a car, how much should they charge to maximize their revenue? So they would like to know what price should they charge the customers per car so that their revenue will be maximized. So now let us see how we're going about doing this. Let's look at step number 1. It says formulate the revenue function. So we need, if we want to maximize revenue, we need a revenue function. All we've got now is the number of cars function. So it goes on to say the revenue function in terms of price is the product of the price per day and the number of cars rented, N of P. Obviously, if one mango costs $1 and you sell 5 mangoes, you multiply the number of mangoes by the cost per mango to give you the revenue, okay, the price per mango. So therefore, you have to multiply the price by the number of cars rented. Now, the number of cars rented now is actually a function, okay? The number of cars rented is modeled by the linear function N of P is equal to 1050 minus 7P. So the revenue function is given by the price times the number of cars function. So that's price, and in a bracket, 1050 minus 7P, all right, in a pair of brackets. So revenue is equal to price times number of cars. Number of cars is not a number. Number of cars is actually a function. Okay, but yet still, nonetheless, it is number of cars. So price times 1050 minus 7P within brackets. You clear brackets, so P times 1050 is 1050P, and P times minus 7P is minus 7P squared. So here we have the revenue function, which of course we can maximize. So step number 2 say, let us determine the optimal price. Okay, what's the maximum price? So the revenue function, R of P is equal to minus 7P squared plus 1050P. They just rearrange it a little bit, put in minus 7P squared as the leading coefficient. Is a quadratic function that opens downwards since the coefficient of the P squared term is negative. Okay, so you'll get like an N, meaning it's a maximum value occurs at the vertex. Okay, the price P that maximizes revenue can be found using the vertex formula. P is equal to minus B over 2A for a quadratic function in the form of AP squared plus PB plus C. Using A is equal to minus 7, B is equal to 1050, we have minus 1050 over 2 times minus 7, which is equal to 1050 over minus 14, which is equal to 75. So the optimal price is $75. This price is within the specified range of $60 to $300 per day. So the answer is the owner should charge $75 per day to maximize their revenue. Now there is another way to calculate this using calculus, which of course that's what we are interested in. Here we are going to outline 4 steps to maximize or minimize a function to get the optimal value using calculus, specifically differentiation. So first you have to differentiate to obtain the gradient function. You must differentiate the function in order to obtain the gradient function. All right. Whenever you differentiate, you have obtained the gradient function. Now you're going to equate the gradient function to 0. Okay. Make it equal to 0 because at the vertex, the gradient is equal to 0. At the optimal value, the gradient is equal to 0, be it maximum or minimum. So you're going to equate that gradient function to 0. Then you're going to solve for the variable. Okay. The value of the variable that making the gradient 0. So you're going to solve for that value. Automatically, that will give you the optimal variable, the optimal value. So then you substitute the solution in part 3 into the original function to obtain the specified value. Okay, but the main thing is that you've got to differentiate equal to 0 and then solve for the variable. Okay, so here now our function is n of p is equal to 1050 minus 7p. That's the number of cars function. To find the revenue function, you multiply by p, which of course we did already, 1050p minus 7p squared. So this function there is the gradient function, 1050 minus 7p squared. So we're going to differentiate this function. Here, p has a power of 1. So now we know the power rule, 1 times 1050, p raised up to the 1 minus 1, minus 2 times 7p, 2 raised to the 2 minus 1. We are applying the power rule there, which of course we are familiar with. So 1050p turns to 1050 because p to the 0 is 1, because 1 minus 1 is 0, right? So we are left with 1050. And here now, minus 2 times 7 is minus 14. 2 minus 1 is 1, minus 14p. So this revenue function is actually a gradient function. Okay? This R prime function is a gradient function. So second step now is to equate it to 0. So with 1050 minus 14p, we're going to equal it to 0. And then we're going to solve for p. So we add minus 14p on both sides so that it can become positive on the right side. So we have 1050 is equal to 14p. And then we divide by 14. So 1050 divided by 14 will give us 75. So the maximum price, the price that the rental company should rent their vehicle is $75, as was obtained before, in order that the revenue will be maximized. So we have found the optimal value of P using 2 different methods. But we are promoting the method using differentiation. Differentiate the function, equate it to 0, the gradient function equate it to 0, and then solve for the variable. If we want to obtain that revenue itself, then we substitute the 75 into the original function to find the number of cars. That will be, to find the revenue, the number of cars and the revenue, the maximum revenue itself. But here we are not interested in maximum revenue. We are only interested in the price to get that maximum revenue. But if you are interested in maximum revenue, we substitute 75 into the revenue function to obtain the maximum revenue. And the number of cars, we substitute 75 into the 1050 minus 7p to get the number of cars that will be rented.